Hello and welcome to a video on analyzing graphs of unfactored. These are unfactored polynomials. This is case 4. This is the highest degree terms that we're going to be looking at, and these are not factored, so we have to start off by factoring. So we're going to look at our this case just a binomial. This looks like it's going to be involved with the sum of cubes, but these are not cubes right now. We need to first take out the GCF. And the GCF for this one is 2x. So let's just rewrite this as 2x times 8x to the third plus 27. Now those are both cubes. This one, the 8x cubed, is 2x to the third, right? 2 cubed is 8. X cubed is x cubed. And this one is 3 to the third. And those are still going to be multiplied by the 2x. And we're looking for zeros, right? So this is all equal to 0. All right, so we're going to follow the pattern for the sum of cubes. So the 2x is going to get carried down. We have a small parenthesis for the binomial, larger parenthesis for the trinomial. This is our a and this is our b. So it's going to be 2x and a 3, 2x squared, which is 4x squared, right? The square of the a. And then 3 squared, which is 9. And then in the middle is the product of 2x and 3, so that's 6x. And then we've got the same sign, which is plus, so it's plus minus plus. Now, we know that this is going to be an irreducible trinomial, so the only place we're going to get x-intercepts are from the 2x equals 0 and the 2x plus 3 equals 0. And this has no real solutions, so we're not going to get, or I should say no real zeros. We're looking for zeros here, so I'm just going to say no real zeros. Okay, so our zeros that we get from this, we get a 0 from this one, right? Divide both sides by 2. So we have x equals 0. And this one, subtract 3, divide by 2, and we get x equals negative 3 over 2. Okay. As far as a y-intercept, if we set the x is equal to 0 here, we're going to get 0. So we have a y-intercept. These are both multiplicity of 1. Okay. We have a y-intercept of 0. As far as end behavior model, it's sitting right there in front of us. We just need to know where to look. So the end behavior is y equals 16 x to the fourth. And we are now ready to graph it. So we would take out our graphing calculator and put this in your calculator, and I'll show you what the graph looks like. Okay, so there's the graph that we're looking at, and this only goes from -3 to 3 to get a good view of the graph. Now it's distorted. It's not a parabola, but it looks kind of like one. It's just not symmetrical. And we've got the y-intercept of 0 and the x-intercept of 0 right there. And then we know this one is -3 over 2. Okay, and a little bit of work to find the local minimum, and we'll see that that local min is at -0.9 and -38.3. So now we've got all the information that we need to be able to finish describing this graph. So let's just describe the domain, the range, where it's increasing, where it's decreasing. Okay, so the domain is still a polynomial, so it's all real numbers. The range, we can see the lowest y value is -38.3, so the range goes from there up to infinity. So -38.3 to infinity. It's increasing from -0.9 to infinity. And it's decreasing up to -0.9. So from negative infinity to -0.9. Okay, that's the first one. Let's look at example 2. So let's analyze a function that's in quadratic form. So this one, we know that this is in quadratic form because the middle term is half the degree of the first term. So we're going to do a u substitution and let u equal the middle term variable, so x squared, which means u squared is x to the fourth, and we can then plug that in, and we're going to get u squared minus 4u plus 9, and we're going to look for the 0, so we're setting that equal to 0. That's a factorable trinomial. Maybe it's not. It doesn't look like it is factorable. Okay, so once you look at it and you realize it's not factorable, you're going to use the quadratic formula. So that we're going to use u equals negative b plus or minus the square root b squared, which is 16, minus 4 times a, which is 1, times c, which is 9, all over 2 times 1. And we're going to get a negative number in there, so we're not going to get any real zeros from this. So we have, whoops, so we have 4 plus or minus the square root, negative 16 minus 36 is negative 20, and over 2, so this is no x intercepts. So everything's going to really depend on the graph that you see in your calculator. So let's go ahead and graph that. Okay, so there's the graph. I'm using negative 5 to 5, negative 10 to 20. That's what the shape is. No x-intercepts as we expected. We should probably look at the function and say what is f of 0 to get our y-intercept, and that's 9. So the y-intercept is 9. And the end behavior is x to the fourth, so that's y equals x to the fourth. That's our end behavior. And what we got is consistent with that. This is a 9 right here. And a little bit of searching for our local maxes and local mins here. Now this function looks very symmetrical on the calculator, and I think it actually is symmetrical. This point right here ends up being negative 1.45. So negative 1.45. This point here ends up being our 0,9. So that local max is in fact 0,9. It's as symmetrical as it looks. And the local max, we shouldn't assume that the local max is the y-intercept, even though it looks like it on the graph. But after you look at the local max and it's pretty much 0, and remember the calculator rounds, so it's like 0.00005 or something like that. But it's close enough. And this local min is 1.45. So we do see some symmetry there, 1.45. So we could actually think about this, whether it's symmetric or not to the y-axis, by just finding f of negative x and thinking of this as, is this an even function? Because if it does have symmetry to the y-axis and it is an even function, then we would get f of negative x is the same as f of x, and we do get that. So you could just do kind of a quick check for even. We don't really need to do this, but it's a good idea to sort of connect this and sort of understand that, when we look at the graph, it looks even. We look at the equation, it may not look even if you think about it, but it actually is, because f of negative x is actually the same thing as f of x, because the negatives would just square away. There would be no negatives left, so you would have the exact same thing. So yeah, this is of course an even function once you think of it that way. All right, now once we're looking at this graph, we've got all the maxes and mins, we can finish the analysis. We've got domain, range, increasing, decreasing, okay, and the domain is all real numbers. The range looks like the lowest value on the function is 5. The lowest y value is 5. So it's going to go from 5 to infinity. Let's just go from left to right. So going from left, it's going to be decreasing from negative infinity to negative 1.4. It's going to be increasing from this min to this max, so from negative 1.4 to 0. Decreasing again from 0 to 1.4. and then increasing one more interval, the last interval increasing from 1.4 to infinity. Okay?